Hello viewers, this is Wagada Ronald taking you through the tutorial on how to calculate median and quartiles for grouped data. So we shall do so by providing a solution to this problem. So a certain junior school admitted 160 children in a particular year. The ages of the children are given in the table below. So these are the ages and these are the number of children with the corresponding ages. And they want us to calculate 1, the median, 2, lower quartile, 3, upper quartile, 4, quartile range, and lastly, semi-interquartile range. So this age in years denote the class. So come and put your class, then rewrite that column here. Then the number of children denote the frequency. So you put those values in this column of frequency. Then now for the class boundaries, remember this is an open interval with only lower class boundaries. So the first thing to do, rewrite these values here. So what is here is what you put here. What is here is what you put here, like that. So you do the same for the rest until here. Now you notice that this value is not known because there is no class after it. So what do you do? So you have to generate a column of class width. That was the class width got by subtracting upper class boundary minus lower class boundary for each class. So this minus this will give you 25. When you do the same for all these ones, you'll get 0.25, 0.25, 0.25 throughout. So that means that if all these ones are 0.25, then even this one has to be 0.25. And now since it is 0.25, you say 0.25 plus 6.25 to get 6.50. So in that way you have generated the column for class boundaries and class width, and so in that case, so from there we can now generate the column of cumulative frequency. How is it generated? It's got from the frequencies. You will keep on adding. So 0, the starting value on frequency, the starting value on cumulative frequency. The next value is got by adding. So 0 plus 20 will be 20. So the next value here will be 20 plus the next frequency, which is 70, to get 90. The next value will be 90 plus the next frequency, which is 36, to get 126. Then the next will be 126 plus the next value, which is 14, to get 140. Then 140 plus 6, you get 146. And 146 plus 10, you get 156. 156 plus 4, you get 160. So that is how the column of CF is generated. So having generated that table, we shall now come to answer the questions that follow. The first question was median. Now before you get the median, you have to identify the median class. And for you to identify the median class, you will first get the position of the median. So the position of the median is a half n, where n is the total frequency. So when you come here, the total frequency will be this, which is 160. So half times 160 is 80. So the 80th position is the position of the median. Now in the column of CF, we are going to look for a value which is slightly greater or equal to 80. So when you come to this is less, 20 is less, but this one is greater than 80, and it is the one which is slightly greater, because from 20 you go to 90. So this becomes our required row of interest, where this is the median class. Now we shall use that row to find some parameters. So median is given by the formula LM, which denotes the lower class boundary of the median class. So if this is the median class, go to the column of class boundary. Now this is the lower class boundary of the median class, so our LM will be 4.75. Then plus, in brackets, a half n. This one denotes the position of the median class, so which is 80. Now you put your 80 there, minus CFB is a symbol to denote cumulative frequency before the median class. So when you look at this median class, before the median class, it is this. Now the cumulative frequency before is 20. So we shall put our 20 there. Now the FM denotes the frequency of the median class. Go to the median class, get the frequency, which is 70. So put your 70 there. C denotes the class width of the median class. Go to the median class width is 0.25. So come and put your 0.25 there. When you use a calculator, you'll be able to get your median in that way. Part Roman 2 was getting the lower quartile. Lower quartile, first of all, like we have done for median, we have to get the lower quartile position. Lower quartile is a quarter n, and the position will be 40th. Now look for a value slightly greater than or equal to 40. Which come to this column of CF. 20 is less, 90 is greater. So this will be our lower quartile row, where this is the lower quartile class, and we shall use it to get the parameters. So in this case, this symbol Q3, we are on lower quartile. This symbol Q1 denotes the lower quartile, and L1 denotes the lower class boundary of the quartile class, which is 4.75. A quarter n denotes the position, which is 40, so put your 40 there. CFB denotes the cumulative frequency before the quartile class, which is 20, so you put your 20 there. F1 denotes the frequency of the lower quartile class, which is 70, so you put 70 there. C denotes the class width of the quartile class, and we already saw that it is 0.25. So 0.25, you put it here. When you use a calculator, you'll get 4.821. So that is how they calculate the lower quartile. For Roman 3, they want the upper quartile. So we shall do the same. First, get the position of the upper quartile, which is 3/4 of the total frequency, and that is 120th position. So look for 120. From 90 go to 126. So this becomes our row of interest. So we shall use it to substitute the formula. Q3 is the symbol to denote upper quartile. L3, lower class boundary of the quartile class, which is 5.00. 3/4 of n is the position, which is 120. Then CFB is the cumulative frequency before the upper quartile class, which is 90. Then F3 is the frequency of the upper quartile class, which is 36. And C is the class width of the upper quartile class, which is 0.25. So when you substitute that and use a calculator, you'll be able to come up with 5.208, which is the upper quartile. Now for Roman 4, they wanted the quartile range. Quartile range is the difference between the upper quartile and the lower quartile. So the upper quartile is 125/24 minus the lower quartile 135/28. So we'll get 65/168, which gives you 0.3869. So that is the quartile range. Then Roman 5, they wanted the semi-interquartile range. Semi-interquartile range is equal to the quartile range divided by 2. So when you get the quartile range and divide by 2, we'll come up with the semi-interquartile range, which is 0.1935. Thank you for watching. I'm Ronald Welgada. Please subscribe to my channel, Rowa e-learning platform. Thank you.